Well, dear students, in last video I told you about photoelectric effect and the observations of photoelectric effect were first one that a number of photoelectrons proportional to intensity. In brief, I am repeating again, number of photoelectrons emitted by photocathode proportional to intensity of radiation, and they were found to be independent of frequency. Number two, maximum kinetic energy of photoelectrons depends on nature of photocathode and intensity of and frequency of radiations. Higher the frequency, more is the kinetic energy of photoelectrons. These were the observation, or these are also called as laws of photoelectric effect. And number three, for every metal, there exists a lowest frequency below which there is no emission. Of electrons, and this frequency was called critical frequency, nu c. Number four, if frequency of radiation falling on photocathode is above critical, then there is no time lag between incidence of radiation and emission of electrons. You know it very well. So why this whole thing happening? We started when some high frequency radiation fall on photocathode, then electrons are emitted. So nature of radiation, was established by phenomena of diffraction, interference, and even by Maxwell theory, that these radiation are electromagnetic radiation, wave character is possessed by radiation. What is wave character? I have told many times that light wave consists of electric field, magnetic field, and energy is transferred by the time varying electric magnetic field from one place to another. So people try to explain the phenomena of photoelectric effect with the help of wave nature of radiation. Why these observations are there? Why the intensity of why the number of photoelectron depend on intensity? Why the kinetic energy depend on frequency? And why there exists critical frequency? To explain all these things, first of all, people applied wave nature radiation. So here I am writing failure of wave nature of radiation. Failure of wave nature of radiation. Failure of radiation to explain phenomena of photoelectric effect. Generally, I have seen people don't explain this topic, and one year there was question on in CBSE board exam. Explain how wave nature of radiation failed to explain phenomena of photoelectric effect. Intensity of radiation. Problem is there, we don't understand what is intensity. You know, intensity of radiation. Intensity of radiation is the measure of energy falling on unit area per unit time. I have told you many times, okay, please remember and understand the definition of intensity. Intensity means energy transferred. Basically, the energy transferred per second per unit area, which is at right angle to direction of propagation, is the intensity. So, when radiation fall on cathode and we increase the intensity, then what is happening? We are increasing energy. So, on increasing the intensity, of radiation, kinetic energy of photoelectrons should increase. So, on increasing the intensity of radiation, kinetic energy of photoelectrons should increase. Not the number. But since intensity is the amount of energy falling per unit area per unit time, so when suppose here this is a photocathode radiation are falling, we are increasing intensity, so electrons should come out with greater kinetic energy. And this is contrary to observation. Kinetic energy depend on frequency. So number of electrons emitted should not depend on intensity, should be on anyway. Number 2, frequency of radiation. Means number of waves So when frequency of radiation falling on cathode is increased, then of waves falling on cathode increases. Hence, the number of photoelectrons should be proportional to frequency of radiation. But practically, this is not there. Number of photoelectron increase intensity. So these two predictions made by wave nature radiation failed. Next, number 3 was there. There exists critical frequency below which no emission of electron take place, how intense the radiation may be. So third point is there. Now if we continuously allow the radiation to fall, radiation carry energy. Later or sooner, electron will take sufficient energy which they require to come out. I told you, free electron inside metal can come out of the metal if they are given energy. So when radiations are firing on photocathode continuously, then later or sooner, electrons will get sufficient energy to come out of the metal surface, and therefore concept of threshold frequency or critical frequency should not exist. I think I no need to write on the board. I am explaining again. If radiations are continuously falling on metal surface, later or sooner, electron will get sufficient energy to come out of the metal surface, and therefore there should not exist the concept of critical frequency. At any frequency, electrons should be emitted, but practical fact is that below a certain frequency, electrons are not emitted. Fourth point, time lag. If it is the point source here of radiation, then waves start traveling in the form of wavefront. So energy of radiation produced by the source get distributed over the wavefront. For example, I am speaking here, my sound is going around, and the sound become inaudible at large distance because the unity per unit area becomes smaller. I have told that intensity equal to P upon 4 pi r square. To larger the distance, greater the radius of the wavefront. So wavefront are very large in size, and electron is very small. Electron is very small in size. So from every wavefront, electron get very small amount of energy, and therefore there should exist a sufficient time lag between incidence of radiation and emission of electrons. time lag. I am explaining that energy of wave is distributed over wavefront, and energy per unit area depend on distance 1 upon r square Boswell. Electron is very small. The energy produced by source gets spread in larger and larger area. By calculation, if you calculate by energy per unit wavefront, we calculate and find that there should exist a large time lag for emission of electron. So this way we can say that all the predictions made by wave nature radiation are contrary to the experimental observations. All the four observations could not be explained with the help of wave nature of radiation, and this way we can say that wave nature failed to explain the phenomena of photoelectric effect. I hope you will enjoy, and please listen and watch the video very carefully. This is important topic here, just to understand physics as well as for exam point of view. Then how to explain? Why this is happening? Why the photoelectric taking place? So this phenomena photoelectric effect was later explained by Einstein using Planck quantum theory. In next video I will discuss the explanation or Einstein theory of photoelectric effect. Einstein explained the phenomena of photoelectric effect using Planck quantum theory. Planck's quantum theory. I have explained many times meaning of quantum. Quantum word confuses the students, and please, if anyhow you don't get my sound or you don't get my explanation, please see the word meaning. Quantum means quantity. According to Planck, light travels in the form of small packets of energy. A small packet of energy is a well-defined energy packet. This is called a photon. He called it a photon. Planck theory. क्या कहते हैं कि light travels in the form of small packets of energy, and this small packet of energy is quantum of energy, or which is called photon. You might have heard somewhere. I'm actually very serious about this word of meaning of quantum. This word is derived from quantity. I have heard many times that the case has been decided. Some case of murder or any wrongdoing is finalized. Then I have heard the anchor saying that case has been decided, but yet the quantum punishment is yet to be decided. So how much will be the punishment that is measured also in quantity, so that is called quantum. So E equal to h nu. is the energy of packet of light energy, which is called photon, H, Planck's constant. Planck's constant, and it is equal to 6.6 in nearly 10 to the power minus 34 joule second. New frequency of wave, which is equal to c upon lambda. C is the speed of light, lambda is the wavelength of light. So taking this theory, in next video I will be explaining you Einstein theory of photoelectric effect. Thank you.